Okay, now that we've discussed the example of the two kids carrying a weight up the stairs in the videos that you watched online and in the Google Slides presentation, we're going to work through a couple of extra work and power example problems, and then I'm going to give you a worksheet to do in Google Docs using this example page. So a couple of the things that we have to remember is that when we're calculating work, we have to make sure that the force that is applied in the same direction that the object moves. Because if there's two different directions involved, then we have to be careful on how we calculate work. So in the first example here, it says a truck pulls a trailer 100 meters while exerting a force of 480 newtons for 1 minute. How much work does the truck do? Now remember that work does not depend on time. So we're only doing force times distance here. And it seems that if the truck is pulling the trailer 100 meters, that both the force and distance are in the same direction. So we can use the force of 480 newtons multiplied by that distance to calculate the work done. So work equals 480 newtons times 100 meters. And when we multiply that out, we get 48000. That's 48,000. And the units for work are joules with a J. But remember that a joule is synonymous with 1 Newton times 1 meter. So it's important that the force and the distance are in those units in order for this unit to be joules. Now the second part of the question asks how much power is produced. Power is dependent on time. Power is work divided by time. We already know how much work was done. The truck did 48,000 joules of work. And how long did it take to do the work? The time is 1 minute. Now again, here we have to be careful because the unit of a watt, which is what we measure power in, 1 watt is 1 joule per second. So it's important that we don't use minutes here for the time. And we should all know that in 1 minute there are 60 seconds. So in doing this now in our calculator, 48,000 joules divided by 60 seconds, the truck produced 800 watts of power. And we should probably circle our work done as well. Now let's look at a different example. This one says a FedEx guy lifts a 50 Newton box and carries it 50 meters to your door. How much work did he do carrying the box to your door? So that's important, okay, because this is saying that I have this guy here, this FedEx guy. I think they wear like a hat sometimes, don't they? And he first lifted this box up, which, if we knew how high he lifted it to carry it, we could calculate how much work he did here. But that 50 newtons is the weight of the box, and that is not the same in direction as him traveling 50 meters to your door. Which means we need the force that he exerted, F exerted horizontally, but we don't have that information. We don't know how much force it took him to walk that box 50 meters. It's not the same force as it would take him to lift it, say to a height of 1.5 meters, because he's walking it this way. And that's the question. How much work did he do carrying the box to your door? And if we don't have this force exerted horizontally, we would assume that it's 0 newtons of force, which means in this example, work equals 0 newtons times 50 meters. We would have to conclude that he did 0 joules of work. That's how important the direction is. Now, I will tell you that not every problem is going to be straightforward, where you plug in force and distance and multiply, or you have work and time and you have to divide, just like when we were in class. You may have to rearrange these to solve for the missing variable. But remember, these are 3 variable triangles. So we can put them into, 3 variable equations, and we can put them into algebraic triangles to help us solve for the missing variable. So this may be something you want to jot down for when you do the problems that will be on the worksheet. Work would be on top here, because force is multiplied by distance, and then work is divided by time to calculate power. So these are these 2 equations for work and for power in the algebraic triangle to help you with the calculations. And remember, if you have any questions, you can email me. You can send me a comment in the private comment section of the assignment, and I will do my best to clarify what they're asking for or what they want you to solve for. I hope everybody's doing well. Good luck on your worksheet.